All right, for lesson 93, we're going to talk about products and quotients of rational expressions. Before we get into this, what are rational expressions? And you've heard that term before. Rational expression, all a rational expression is really it's just a fraction. So for example, if I had a over 2, that's a rational expression. Or if I had x squared minus 25 over x, that's a rational expression. Anything that's in the form of a fraction is a rational expression. Now, also going in the lesson, we need to review a little bit how you divide fractions, since we're talking really about fractions. So if you had, say you had a over 3 divided by, let's say 6 over 7. Okay, now to divide fractions, remember we really change it to a multiplication problem. But when you change the division to multiplication, what do you have to do with the fraction or the number that follows the division? You got to flip it or take the reciprocal of it. So really, this is what I have then. Now another thing to keep in mind is once we get it to a multiplication problem, once it's in multiplication, then we can cross cancel if there is cross canceling available. Notice here that with the a and the 6, there's nothing to cross cancel, nor is there anything to cross cancel with the 3 and the 7. But only when you're multiplying can you cross cancel. Notice up in our original division problem, we cannot cross cancel here because it's still division. We got to change it to multiplication before we can cross cancel. Now let's take a look at example 1, and this is it says simplify. So really I've got a fraction times a fraction. That's really what we see here. So this is a fraction, this is a fraction, and we're really just multiplying two fractions. And the problem though is before we can do anything with this, we really got to break down what we have. And if you look at the first fraction here, notice that I have a binomial on top and I have a binomial on the bottom. And what we're going to do here is we're going to simplify those. We're going to factor those. So notice the binomial in the top is the difference of two perfect squares. And remember, the difference of two perfect squares is always a plus and a minus. And then we can break that down to x and 5 and x and 5. And if I FOIL that, I'd get x squared minus 25. In the bottom, it's a binomial, but it's not the difference of two perfect squares. So I can't do anything that way, but I can notice that there is an x that's common in both of them. I can factor out an x. And when I do that, I have x minus 7 left, like that. Now if I check that and I distribute the x, let's see, x times x is x squared minus 7x. So I did it correctly. So what we've done in the top and the bottom is we factored both those. Now we're going to do the same thing with the other fraction. Now on the top, on this one right here, I can factor out an x because something is common in both of them. That leaves me with x plus 3. And then in the bottom, that's just a plain trinomial that we can factor. And the second sign is minus. That means we have two different signs. Give me two factors of 15 where the difference is 2. That would be 5 and 3. The larger factor goes with the first sign right here of minus. Now, what I have now is I factored everything. This problem is multiplication. Now, this is the point where we can do quite a bit. And notice that there's opportunities here to cross cancel. So notice here I can cancel out an x and an x. All right. Now, is there anything else common? Notice that I've got a couple of x minus 5, and this is a couple. That's the only way I can cancel out a couple is if it's the whole couple. So in other words, I cannot just, for example, I cannot just cancel out an x here and an x here because those x's are part of a couple. But what I can do, though, is I can cancel out the whole couple because they're the same, x minus 5 and x minus 5. Now, I want to review some here up above here on the top right. If I have, say I have 3a over 3. Notice here I can cancel out some 3's, right? Well, I can do the same thing right here. I can cancel out this couple, and I can cancel out that couple. Now, there's nothing else I can cancel out. So what do I have left in the top? Well, I have an x plus 5, that couple, right there. And then the bottom, all I have is an x minus 7. And we're done. We've simplified this rational expression. So my answer then is x plus 5 over x minus 7. Let's take a look at one more example. This time it involves division. Now before I before I do the division, let's do some simplifying here. So let's do what I did in the previous example, and let's factor the tops and bottoms. So in the top, right here, that's a plain trinomial that I can factor. Let's see, it's a plus and a minus, x and x, right? Two factors of 6 where the difference is 1, 3 and 2. The larger one goes with the first sign of minus. In the bottom, I can factor that trinomial. And again, it's a plus and a minus, x and x. Let's see, give me two factors of 8 where the difference is 3. So that would be, let's see, and I'm looking at it here. Let's see, two factors of 8. Let's see, 2 and 4. That's not going to work. 8 and 1. So nothing works there. And it seems like most of these problems that you will get, and I can see what let's see, x squared. I'm just checking the original problem that I had written down. Okay, I can see what happened. The original problem, so really right here, this should be a 10. The original problem up here, this should be a 10. So let's change that to 10. So now we can factor it. So I want two factors of 10 where the difference is a 3, and it would be 5 and 2. So the 5 goes with the first sign, and then the 2 goes there. Okay, now we got it. All right, in the top right one now, let's see if we can factor that, and if I wrote it down correctly, we'll be able to. This time the second sign's plus, so they're both the same, and look at the first sign to determine they're both pluses, so x and x. Now I want two factors of 4 where the sum is 5, and that would be 4 and 1. All right. In the bottom one now, should be able to factor it, plus and a minus, x and x. So I have two different signs. Give me two factors of 20 where the difference is 1, and it would be 5 and 4, with a 5 going with the first sign, the minus. All right, now what I need to do is, before I can do anything with cross-canceling, I got to make sure I write this as a multiplication problem. So I'm going to do that. So I have x plus 2 times x minus 3 over x plus 2 times x minus 5. Now I'm going to change it to multiplication, but I need to flip the top and the bottoms here. All right? So now I have the x plus 4 in the bottom and the x minus 5 in the bottom. Now they're in the top. And then I bring these down below. So x plus 4 and x plus 1. All right, let's cross cancel where we can. As long as I got a top value and a bottom value, I can cross cancel. So what I'm saying here is, okay, I can cancel out these couples, right? What else? I've got an x plus 2 and a couple of an x plus 2. Do we see anything else? Yeah, I've got an x minus 5 and another couple of an x minus 5. Now, that's all. I cannot just cancel out an x here and an x here because it's part of a couple. So what's left in the top? In the top is I have an x minus 3, and in the bottom I have an x plus 1, and that's it. I'm done. I've simplified this rational expression.